Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. In this video, I would like to discuss about basic countings, where the topic that I want to discuss is topic 1.1, counting argument. So, these are the objectives for this topic. The first one, I want everybody must know how to solve counting problems by using product rule. And the second one, I want everybody must know how to solve counting problems by using sum rule. So, for the introduction part, okay, we often face problems of counting objects having certain of properties. In order to meet our needs, we must count certain objects or number of possible ways of doing a particular job. Counting problems occur throughout mathematics and also computer science. For instance, in computer science, we count the number statements executed in algorithm analysis. Here are some of the applications that can be used for this subtopic. The first one, we can use to determine whether there are enough telephone numbers or internet protocol addresses to meet the demands. Or another application, we can use to enumerate the different phone numbers possible in Malaysia, the allowable password on a computer system. Okay, under basic counting principle, we have two rules. Okay, the first one is a product rule and the second one is a sum rule. What is the difference between these two rules? Okay, for product rule, this is applied when a procedure is made of separate tasks. So these are the keywords for product rule, separate tasks. While for the sum rule, this is applied when a task is made up of different ways. So the keyword for sum rule is different ways. Okay, so now let's discuss about product rule first. Let T can be completed in K successive tasks. Suppose T1 can be completed in N1 ways, while T2 can be completed in N2 ways. So, in general, no matter how the preceding tasks are completed, task K can be completed in Nk ways. Then the task T can be completed in N1, N2 until Nk, different ways where K is the number of the tasks. So this figure shows the illustration how the product will works. Okay, so for T11, okay, have several ways. So T11 can be paired with T21. T11 also can be paired with T22 and so on until T2N2. So same goes to T12. It can be paired with T21, T22 and so on. So how to find the total number of the different ways? So the total number of the different ways is N1 multiplied with N. Okay, so for better understandings, let's try several examples. So for example 1, there are 32 microcomputers in a computer center. Each microcomputer has 24 ports. How many different ports to a microcomputer in the center are there? So firstly, let's list all the information that we have. Okay, the information that we have. The first one, we have 32 microcomputers. And also, in each microcomputers, we have 24 ports. Okay, so how many different ports? So how to solve? We are going to solve by using product rule. Okay, so I use the illustration first for better understanding. Okay, let's say this is the first microcomputer, second microcomputer, third microcomputer until 32 microcomputer. And we also have 24 ports. That means this is the first port, the second port, the third port until 24 port. So, how it works product rule? The first microcomputer can be paired with the first port. Also can be paired with the second port. Also can be for with the third port until 24 port. So this is for the first microcomputer. How about the second microcomputer? The same thing happened. The second microcomputer can be paired with the first port, can be also paired with the second port until 24 port. And it goes for the third one also. And it will happen until 32 microcomputer. So, how many numbers of ways? What is the total number of ways? So, the total is 32, you multiply with 24. So, the answer is 768. Okay, so now let's try for example number 2. So, the chairs in a lecture room are to be labelled with a letter and a positive integer not exceeding 100. What is the largest number of chairs that can be labelled differently? Okay, so we are going to label a lecture chairs. Okay, so how we are going to label this chair? Okay, by using two combinations. Okay, so the first one by using a letter. And the second combination is by using a positive integer. But the integer cannot exceed 100. Okay, so from here, how many letters that we have? So we have start from A, B, C until Z. So we have 26 letters. Okay, so now, how about the integer? So positive integer, it will start from 1, 2, 3 until 100. Okay, we will stop until 100 because the condition said, okay, not be more than 100. So what is the total number? So we will have 100 numbers. So what is the largest number of chairs that can be labeled differently? So by using product rule, it will work. A can be combined with 1. A can be combined with 2, with 3 until 100. And then same goes to B. B with 1, B with 2, B with 3 until 100. And we will repeat the process until Z pair with 1, 2 until 100. So, how different ways or what is the largest number of chairs that can we label? So, by using product rule. So, we will have 26 multiplied with 100. So, we will have 2600 chairs. Okay, now let's try another example. So, example 3. Melissa is a baker. She wants to deliver her cakes to her customer in place A in the morning and place C in the afternoon. She looks at the map and finds that there is no direct route from place A to place C. And on further checking, Melissa realized that she also has to deliver the cakes to the customer in place B. Then she finds that the place B is located in between place A and also C. So she decided to deliver her cakes at place B while delivery from A to C. There are 4 routes M1, M2, M3 and M4 from A to B, while there are 3 routes N1, N2 and N3 from B to C, as shown in the figure below. So, in how many ways can Melissa go from place A to C and at the same time deliver cakes in place B? Okay, so this is the map. Okay, Melissa are going to deliver the cakes from A to C. And in the same time, okay, she also needs to deliver in B. So from A to B, they have 4 routes. While from B to C, Okay, she have 3 routes. So how many possible routes that she can use to deliver from A to C? So by using product rule. So this is a very simple. So product rule. So 4. This is 4 routes from A to B. Multiply with 3 routes from B to C. So Melissa have 12 possible ways to deliver her cake from A to C. Okay guys, so now let's try the last example in product rule. So example 4, find the number of words of length 3 that can be written by using letters A, B, C, D, and E, and a repetition of the letters in a word is allowed. Okay, so now we want to write a word with 3 letters. The first letter, second letter, and the third letter. Where the letters that can be used only for A, B, C, D, and E. And the condition said, okay, repetition of the letters is allowed. Okay, that means for the first letter here, we can start with A, B, C, D, and E. How about the second place? Okay, since repetition is allowed, so that means you can start again from A, B, C, D, and E. And for the last place, okay, since the repetition is allowed, so you start again from A, B, C, D, and E. So from here, let's check how many possible ways, okay, we can write a word with 3 letters. So we start from A to A to A. And then we also have A, B, A, C, A, D, A, E. And then we start again. A, B, A, B, B, A, B, C, A, B, D, A, B, E. And the process repeat until A to E for the first letter, A to E for the second letter, and A to E for the last letter. So the product rule is, okay, so the product rule. So for the first one, we have 5 ways. Multiply for the second one, we have 5 ways also. And the last one, we also have 5 ways. So 5 times 5 times 5 is equal to 125. Okay, so now let's go to the next rule. That is a sum rule. Suppose a task T is a collection of tasks T1, T2 until Tk. These tasks are called independent if the outcomes of any task does not influence the outcome of any task in the collection. Suppose the task T1 until Tk can be done in N1 until Nk ways respectively. If these tasks are independent of each other, then the number of ways to do of one of these tasks is N1 plus N2 until plus Nk. So these are the illustration how sum rule works. Okay, so we have T1 task T11, T12, T13 until T1N1. And then also or okay, we need to do another task that is a T21, T22, T23 until T2N2. So how to calculate the total ways? So there's a very simple formula. Ways, the total number of ways is N1 plus N2. Okay, so now let's try our understanding about sum rule. So we go to the example number 5. Suppose that either a member of the mathematics faculty or a student who is mathematics major is chosen as a representative to a university committee. So how many different choices are there for this representative if there are 37 members of the mathematics faculty and 83 mathematics major and no one is both a faculty member and a student? So we know we have 37 from mathematics, while we have another 83 candidates from maths major. Okay, and from both of these, we need to choose only one representative. So how to choose? Okay, so for the first choice, okay, we can choose from the mathematic members. So we have 37 choice from 1 until 37. Or if you don't want to choose from mathematic members, okay, you can choose for the second choice. Okay, you can choose one from the mathematics major. That means you can choose from 1 until 83. So the total waste is equal to 37 plus 83. So that means you will have 120 waste. Okay, so now let's try for example 6. A student can choose a computer project from one of three lists. The three lists contain 23, 15, and 19 possible projects. Where there is no project is on more than one list. So how many possible projects are those to choose from? Okay, that means okay, you have first choice. Okay, first choice you have 23 projects. And second choice, you have 15 projects here, while the third choice, you have 19 projects. But you need to choose only one. So from this, how many ways to choose the project? So by using the sum rule, so you will have 23 plus 15 plus 19. That means you will have 57 ways. Okay, so now let's go to the example 7. There are three storage boxes containing different patterns of blocks. The first storage contains 10 red blocks, while the second storage contains 9 yellow blocks, and the third storage contains 7 pink blocks. Muhammad wants to take a block from one of the storage boxes. In how many possible ways Muhammad can do this? Okay, so let's list down all the information that we have. Okay, we have three boxes here. Okay, three boxes where the first boxes contains 10 red, while the second boxes contain 9 yellow. And for the last boxes, box number 3, we have 7 pinks. And Muhammad only can choose one. So how many possible ways Muhammad can do this? So by using the sum rule. So sum rule, that means you just need to add everything. Okay, the first choice 10 plus the second choice 9, or you can plus the third choice 7. That means 10 plus 9 we have 19. 19 plus 7, that means we have 26 possible ways. Okay guys, so now let's try the last example in sum rule. Okay, let's go to the example number 8. So find the number of integers between 6 and 100 that end with 5 or 8. Okay, so firstly, okay, we have a list of numbers, okay, where the list start from number 6, 7, 8 until 100. So this is our list. So we want to choose only one number. Okay, choose one number where the end of the number, whether you have 5 or 8. So now let's denote for the first choice that number with end with 5 as a task number 1, while number with end with number 8 with task number 2. So let's list down for task number 1. Okay, from 6 to 100, the numbers that end with number 5, okay, we have 15, 25, 35, 45, 55, 65, 70, 65, 75, 85, and also 95. So total this number we have 9. Okay, so now we go to the task number 2. What is the number that end with 8? So we have 8, 18, 28, 38, 48, 58, 68, 78, 88, and 98, where the total of this number is 10. So, possible ways. So, how many? So, by using sum rule, so we have 9 plus 10. That means we have 19 possible ways. Okay guys, so as a conclusion, okay, so in basic counting principle, we have two rules. The first rule, we learns about product rule, and the second rule, we learn about sum rule. So how to differentiate between product rule and sum rule? Okay, normally product rule is about you are going to find combination between tasks. Okay, that means you want to combine task 1 and combine task 2. Okay, so how many possible? So the formula is n1 multiply with n2. Okay, some rule is you have many choice, but you want to choose one choice only. Okay, you just want to choose one. So that's mean, okay, so you have choice from T1, you have choice from T2, okay, but you cannot choose the combination. You need to choose between T1 or T2. Okay, the keyword is or. That means the formula is N1 plus N2. So I hope, okay, this video will help you to solve the problem regarding basic counting principle that use product rule and also sum rule. Uh, I hope everybody can understand my explanation about this subtopic. So thank you guys.